we are at is, let's see, here. Okay, so day one is pretty much done. I don't really feel like doing much else here. Oh my god, this NVIDIA notification though. NVIDIA notification. Can we... Why? Oh my god, okay. Alright. Can... Oh my god. This isn't going well. This isn't going well. Okay. So let's quit this. Let's open the settings here and disable all notifications. Alright. Let's verify that GeForce Experience isn't going to get in the way. Yeah. Okay, so part 1, no, day 1 rather. I think this is fine. This is 5 for day 1. Let's do day 2. Now, let me just disable preview there. So day 2 would go in here. Now, I think all of these Advent of Code questions have 2 parts, and the answer to each part is just a number. So really, this first part, where I have, this first part can probably go out. Right, so we have this begin panel solution, and inside of it, we just do this, right? But it has to be wrapped like that. So depending on what solution is active, we do a different thing. Is that right? Yeah, that seems correct. Yeah. Yeah. So really, I wanna pull this out. Actually, I wanna pull this out even more. Okay, so we begin panel solution, right? And then inside of that, we've got layout row and begin panel solution result string, and end panel. And then this goes inside of that. Well, honestly, this can go in here as well. And this can kind of go in here as well. It's just, it's not, we don't even need to construct the string in here, honestly. We just need the 2 numbers. Like, just get me the 2 numbers. So can we do something like this? So this is an expression, right? So like long to like, what is this? Result to numbers, whatever, that works. And then in the first case, the result to numbers is just that. And this. and the result string would be that. So that's your solution selector, that's your solution. Maybe these panels should go inside, I don't know. Yeah, it's a bit better. And that's so begin the whole thing, begin window, layout row, that's for the whole window. And then this first panel, that's the first row, and then in the first column, that's the one that's 200. And then everything follows goes into the second column of the window. Okay. So then we have the solution. Which has its own well, actually that's interesting, because we have the solution, right? And here we're basically saying, okay, so all of this is relevant for the result string. So we lay out a row, we're going to begin the panel and we lay out another row. So this that, yeah. So day 2 and day 3. So those are just that for now. These are ints. Well, it could be an int. I mean, I don't really care too much. Yeah. So now if we just go to these ones and change this to int, and change this to int, I mean, we might have some problems here. Score part 1. That should work fine. And here as well, I mean, it doesn't really matter. Int is fine. Care, int. Cast, int, like we're not gonna have overflows here, that's fine. Yeah, what's going on here then? Why is that stack allocated exactly? Can you not just do this? what escaping reference? What are you talking about? Those two? Escaping reference to stack allocated value returned by that thing. And why is that a stack allocated value exactly? Like, do I have to like unwrap it like this? Oh look, the compiler isn't... No, that is an error message, huh? Well, this is a compiler bug. And I guess the error is that it can't, in order to return a static array, it needs to do something that it's obviously not doing. Or rather, it's generating a call to... Well, it's generating a call to something. I don't know, with all this name mangling, it's completely... nobody knows what it's generating a call to. But it's generating a call to something. And then it's just not including that code. Just out of curiosity, what if I do this? Struct int2 is... well, I know it's struct int2 is... let's just say int x, int y, like that. And then I return that. And then this is gonna be something like int2, and we just sort of replace this with parentheses. Well, if the compiler was less buggy, this wouldn't be such a bad language, you know. The decompiler is bad and incapable of handling int2 here. Okay, well, anyway, the point is that's the result string. And after the result string, what do we got? We changed the row layout, looks like. So interestingly, we don't... Oh no, we do have a panel. Okay, so we change the row layout again. Then we begin the panel for the scale. Okay, does this work as before? Yes, and we have the other parts up there as well. Okay, so basically the state of the UI is that we have a panel, and then we have a row layout, and we have another panel which is ended here. Yeah, so each of these solutions will have to, is essentially free to do whatever it wants inside of the space that's left after the result string. Okay, well, what's day 2? Rock, paper, scissors. Oh, that's right. Rock, paper, scissors is day 2. Encrypted strategy guide. So there is a strategy guide for the rock, paper, scissors game. So what's the first word? Your opponent will choose rock. Okay, so we just have a strategy guide. Okay, so the input predicts and recommends. Yeah. So we just have pairs of letters, and each of those is associated with a number. Okay, well, what can we draw based on that? Well, we can draw the pairs, of course. We can just like essentially print that. And what's the answer actually? Total score. Well, if we want the answer to be somewhat readable, from whatever visualization, then I mean each pair contributes something to a number, and that number then just grows continuously, which is the sum. Oh my god, even. Alright. So, it's some kind of... Well, there was only 3 outcomes: win, lose, or draw. But it's really long. It's a really long sequence, though. So, making it be readable is gonna be... I mean, I guess if you start filling up rectangles, and each rectangle is some amount, 1,000, and then you have 12 of them filled out, and then a bit more at the end. That would make the whole thing kind of readable. I mean, that's something. Again, it's just a whole bunch of rectangles again is what we got, which is fine. I mean, okay, well, the first part would be, I suppose, to get this thing to output not just the result. Okay, so part 1 is just total score. Part 2, that's the two strategy guides. Total score 1 and total score 2. That's really all that is. Total score 1 and total score 2, but then we kind of want the outcomes, except we only really want to know which outcome it was. Well, no, it is a different. So in order to work out the score, you kind of do need to know both what you chose and what the outcome was. Shape you selected plus the outcome. Yeah, I mean, I suppose we could store just a slice of events here, which is like scores. And then, well, I mean, we want to know both, right? So it's like round int score, and then outcome, and we want to store all the rounds like that. Struct round, slice of rounds. Score and outcome. Yeah, what's the outcome? Well, the outcome is, like loss, draw, win. And we just want to store those, yeah. Are we using the arena? We're not using the arena, right, for anything really. And we only have one array to build out, so we actually can just do this round storage. Round storage is dynamic array round from. Wow, that is not what we want, huh? So how do we do our dynamic arrays again? Just give it an arena and the size in bytes. Arena, free size. Just take the whole thing, why not? Okay. And yeah, so they are going to be different though for part 1 and part 2, but yeah, let's worry about part 2 later. So round storage is over here, so let's fill it out. Just with part 1 stuff though. So we don't have anything. Actually, now that we are not being confined to anything by, I don't know, Actually, what if I do this, right? It still compiles, kind of. Yeah, I mean, suppose I can call this score part 1, score part 2. No, I don't need to declare them there. Oh yeah, this is not a slice, this is a dynamic array. So it understands what insert false is. Okay, that's good. Yeah, we'll fix those later. Okay, so given that this is what we've got, there is our rounds. This is the storage. Okay, so at the end of this, we know what the round is, right? Round is score part 1. Well, actually not score part 1. Int score round part 1 is that score round part 1. Int score round part 2 is that, and round is score round part 1. And outcome. Okay, so what's the round outcome? And then we'll just do round storage push round. Yeah, so that's all fine. Okay, so I'm kind of encoding these things. Okay, so choice 1, choice 2, part 1. Score outcome part 2, choice part 2. Well, so all of this is part 2. So this is part 1. Choice part 1 is that, so I'm just encoding them as score outcome. I mean, instead of having a score outcome, we can have an extra step here, which is like actual outcome. I can hit it. And then just have int outcome max. Outcome scores is what is it? 0, 3, and 6. 0, 3, and 6. I mean, isn't that just times 3? Outcome part 1 times 3. Okay, so all of this is to determine outcome part 1. Draw, lose, lose, assert, if draw, outcome part 1 is draw, outcome part 1 is when? It's something like this. And assume loss. No, that should be probably rounds storage. Yeah. Okay, so that's score outcome part 2. And by the same token, this could be outcome. Outcome part 2 is just that. And this is times 3 right here. Yeah. Okay, so we're not really doing much with that. Now, round is score outcome part 1. I mean, at this point, it's pretty obvious, right, that we just kind of want both of those. Score part 1, score part 2. I mean, those could be separate, right? You're probably gonna plot them separately. So, hold on. Yeah, score outcome. Score round, what? Score outcome. Outcome part 1. Yeah, score outcome. Score outcome. So for now, that's just part 1. And that'll be enough. Yeah, so this will be score part 1 and score part 2. Yeah, and then while we're here, static if type name is year 2022 day 2, assert this solution, was it like result, score part 1 is, we want to make sure that it remains correct. Score part 2 is that. Something like this. Okay, does this work? Yes. And what was that? Did micro UI just like take a frame to readjust or something? Like, why did that move? That's really strange. Is it because they have the same, like the panel has the same name or something, so it like thinks that it shouldn't? Oh my god, what? Can we like see it in slow motion? Yeah, we can. Okay, that's not... Oh, it doesn't have a scroll bar. And now it does. Okay, I mean, that's the ever-present problem with these UI things, is that they just don't update in time. Like, you need to draw everything multiple times in order for it to like get synchronized with it. So this is kind of far away, and then it moves closer, and the scroll bar appears. I mean, both of these problems, the fact that this is not in the right place right away, the fact that the scroll bar is not in the right place right away, like both of them are symptoms of just the library design, really. Is that it's designed in a way where it is incapable of getting all of the dimensions, or all of the layout right for the first time. You need to go through it multiple times in order for it to correct all of its conflicts. Yeah, it's this to do. Well, at least I have a to do for that. Does that mean I have to write my own? Oh my god. Because every immediate mode UI library is gonna have that problem. Some variant of it. So yeah, it kinda works when you're updating every frame. Because the 1 or 2 frames where it's wrong, you will just not notice too much. I mean, well, you will. But like, yeah, it'll correct itself quickly anyway, so like, it's not so bad. Like, this is using an immediate mode UI. And it has the same problem, but it is updating every frame, so you don't see it so much. Although this is imGUI, which has all sorts of jank. Like this, like I'm hovering over the scroll bar, but then if I move to the right, now I'm not. Now I'm in the next panel. So there's this weird dead space between the panel and the scroll bar of the next panel. UI sucks. Just all of it is bad. It's all bad. Immediate mode, retained mode, everything's bad. Well, let's do what we can here. Which I guess just means iterate over. Just iterate over the rounds and, draw something. Draw some rectangles for each round. call this qualitative palette. And I guess if we're gonna scroll vertically. Yeah. And draw rect with border. Is draw rect with border available to us? It is up here. Okay. Draw rect with border. So this is gonna be like round rect, qualitative palette, round outcome. That's that. For each round, sol rounds. No, actually we're not done. Hold on. We're not quite done here. That's day 3, hold on. Yeah, because I haven't set rounds to anything. Rounds is rounds storage buffer 0 to rounds storage length. And then we just do arena used is arena used before plus rounds length. I mean, I guess round storage length times whatever it's storing, which is round size of yeah, it works. Okay. So now we just need to work out what this qualitative palette gray. That's what that is. Which is what this is. Right? No, just that. Arena used before unidentified. Oh yeah. Long arena used before is arena used. Round rect is mu. It's mu rect. Round rect is. I mean, let's just do that. Like, okay, so it doesn't allocate anything after all. Okay. Actually, round rect has to be outside because it's going to be changing. start, we need the bounds. So like mu get clip whatever. Mu layout next, that's right. Bounds. I mean, let's just draw one of those just to see what we're even drawing into that. Okay, well clearly that's not what we want. We want to mu actually layout row width whatever -1, height -1. Actually, it's even gonna be higher than -1 probably. It's probably gonna be actually. Let's see what happens. What happens here exactly? Okay, so we can scroll, but I don't want to scroll that. So does that mean we need to do? Okay, so we need to do something like this. We need to lay out a row. And we need to begin a panel. Do we have an example of a panel? Begin panel X. I mean, that is what we want. And then mu and panel mu ctx. Except this is not histogram rects, this is like rock, paper, scissors, out comes. That works. Okay, so that's that. Hold on. So we lay out a row, begin a panel, then we lay out a row again, and this time yeah, so that's what I wanted, yeah. And there's our vertical scroll bar. Begin a panel, lay out a row again. And there's the bounds, and the panel. All right. So we initialize it to bounds, but really round, rect. I mean, the top left is correct. Height should be, well, I mean, we can just do it this way, right? Mu, rect, bounds, x, bounds, y, width, height, like that. And round, rect. Width is going to be determined by the outcome of the rounds. So, well, actually, not even. Round, it's not even the outcome, it's the score, right? Let's do the first 10. Now that is very small, hold on. Well, yeah, I mean, we need to scale it, right? Score, whatever the score is, that needs to be scaled. Well, let's just try to scale it by 10, like whatever. Yep. Is that 10? About 100. What would that? Oh my god. What would that look like? 2, 3, 4. I mean, I'm only seeing 4 rects here. Where are the rest of the rects? Are they like going down? Some no. Well, this is presumably 10 rounds. Oh wait, I'm not moving the rect. Round rect x plus equals round rect w. Okay, let's see here. All right. Well, now they're doing something here. Now they're moving way to the right. Yeah, of course, it's not. They're not gonna like all add up to 1,000 or whatever. What if it's as many pixels as the score? Well, I mean, that doesn't work super well. So we do need to scale it up somewhat. At least like that. And that does look like 10. If round rect x is greater than bounds x, so if we, the next, well, actually that's an interesting, okay, round rect x plus round rect w, so if that's outside the bounds, oh yeah, like that. If that's outside the bounds, then round rect x becomes bounds x, and round rect y is dropped down, so round rect height. And actually, after this, we need to assert that this is still not true. I mean, it's not true now that it's, because we can't handle it if it can't fit. Even if one rect can't fit, that just shouldn't happen. Interesting. Well, we should never have hit this to begin with. How did we hit this? I don't get it. Oh, it's not bounds x, it's alright. It's not bounds x really, it's bounds x plus bounds width. What's that? Yeah. Okay, so well, now we should have some kind of wrapping going on, so let's do the first 100. If there is 100. There is 100. Yeah, well, I mean, that seems like it's doing something there. I still can't read how much this is, but... Okay, what if we do all of them? It's not gonna look like. And that's what that looks like. Yeah, I mean... all we need to do to kind of read off a score is to like count them, so that's easy to see. And I mean, it's still, you're not gonna be able to read over score that easily, but you'll get some approximate idea of what it is. I mean, that's what it is, 12,000, right? So there's gonna be like 11 full ones, and then 12, this is 12, and it's like kinda halfway, presumably. Is that what we're seeing, actually? Well, if each one was 1,000, that's what we would be seeing. But each one kinda does need to be some round number to be able to, for you to be able to easily read it. Because otherwise it's not easily readable. And this is essentially it's the same code, right, for both parts. So the total size, I need to figure that out. Well, we need to figure out how much to fit in a row here. And we don't want to do horizontal scrolling, right? So how much are we fitting in a row? Let's figure that out. So what, like int score per row is, let's say, 1,000. Well, if score per row is 1,000, that means that the width of the rectangle is the score. We want to know what proportion of the total is and max score is, okay, so if this is like 500 or something, if the score is 500, right? Then you divide it by score per row to get 0.5, and then you multiply that by, well, by score per row. I mean, I suppose we can just make this out. We can make, oh my god, what is going on here? We can make this a float, right? So divided by wait, hold on. So if we divide it by score per row, well, that's not really. Well, there's score per row, but then there's also pixels per row, right? There we go. Also build pixels per row, which is bounds width. So we want 1,000, and there's only so many pixels to fit that in. So float score per pixel would be score per row divided by pixels per row. So that's per pixel. But we kind of want the opposite. I think we want pixels per score. So that if you multiply score by that number, you you just get pixels out of it. Right, okay, so let's see. Oh man, okay, let's just see what that is. A score per row, pixels per row, so pixels, so there's 2.28 pixels per 1 point. Okay, so that actually sounds about right. Okay, so presumably now each row corresponds to 1000. Of these. So now, the next step would be so the height of the rack should be font height. Should be that. And now on the left here we can draw digits to know how many. And at the top, I guess, I can draw the scale. And have the grid descend down. Yeah. Of course, these bounds. Okay, I'm gonna do something here. So the bounds are actually they're like complete bounds. It's total bounds. But what we want to use here is specifically rect bounds. But these are not rect bounds, these are total bounds. Mu rect, mu rect bounds would be total bounds. Well, it's gonna be mu rect top axis bounds. So we're gonna have the top axis, which is something, and then we're gonna have left numbers bounds, and we're also gonna have that. And then rect bounds would be what's left. Well, total bounds x plus, well, it's plus however much the left numbers take, plus which is just gonna be font sure width. Although we might want more than one digit to draw, which we know is gonna be 2 digits, right? So like int left number max width is font sure width times 2. Top axis bounds would be that plus that, that's the x, the same y, x width minus, and well, it's not the same height, right? It's top axis bounds. How high does it need to be? Really just the font height? Left numbers bounds is mu rect total bounds x total bounds y plus however the top axis height is, right? That width is gonna be left number max width, and height is gonna be top axis bounds height minus, no, it's actually bounds height, total bounds height minus top axis bounds height. And then the rect bounds would be mu rect total bounds x plus left, well, plus left x plus left number max width, then total bounds, yeah, y is total bounds y plus dope x is bounds height, width is total bounds width, total bounds y. Okay, so width is just minus left number maxed width, and height is well, with font height, like top x is bounds height. So that yeah, it's probably, I don't know. If you ever have to do this again, there's probably a better way to slice up these rects. But, you know, for now this will probably do fine. Rect bounds, so with drawing that within the rect bounds. Yeah, so we moved it down a little, although it should have also moved to the left. Which did it? Doesn't look like it. Oh. Yeah. You know, top x's bounds is it's like I just want to kind of cut this rect in two. Well, really in four, right? Okay, I guess I can do something like this. Rect bounds is total bounds. Top axis bounds is rect bounds cut top font height. Okay. So start with the total bounds, right? Make sure it's not modified. Actually, is this a compile time error to modify it? Like, is this... Yeah. So rect bounds is right here. Then top axis bounds is that. Top axis bounds cut left. Left numbers bounds is rect bounds cut left. So it's cut top, then cut left. Cut left, font character width times 2, and cut left these things by that width. Top axis bounds, cut left. Okay, is that all we need to do? I think it is. So wherever this rect is, I mean mu rect, yeah, these are mu rects, right? So well, actually, I think we could just do something like this. Mu rect cut top mu rect int by, and we just take a pointer here actually, or I guess a ref will do. Mu rect result is rect result height is by, width xy don't change, rect height minus equals by, rect y plus equals by, return result. So would that satisfy cut top? Like, can I just call cut top now? No property cut top. Well, yeah, but there is like a function that does it. I mean, okay, you know what? Yeah, so let's just make them into functions. Cut top, cut bottom, result height is result x plus equals x is result height minus y. No, well, result y. So the resulting rect, if you cut the bottom, is, so the height is that, and the y is actually it's rect height minus by, rect height minus by. Now rect height minus equals by, rect, and that's it. Yeah, that's it. Cut left. Result x, so width is by, rect width minus equals by, rect x plus equals by. Cut right. So result width is by, result x is rect, actually it's rect y plus rect h minus by, and this is rect x plus rect width minus by that. It is and rect width minus by. So left, right subtracts the width, bottom, top subtracts the height. Yeah. Top will move the y, right will move the, no, left will move the x. Okay, so so this is the trickiest part, right? So cut right is x plus width minus by, and the bottom is rect side minus by. Yeah. Cut left, rect bounds, cut left, what is it? Top axis bounds. Okay, so I think the bounds are now what they should be. Total bounds. Rect bounds. Okay, so cut the top of the thing by the font height, whatever that is. Okay, so we've got top axis bounds. So rect bounds now should have that top cutoff, yeah, which seems like they do. Top axis bounds, height 16, so that seems about right. Okay, left numbers bounds. Okay, so top axis bounds is at 235, whereas total bounds is 219, 51. So 235, 67, and this has been adjusted. Okay, so it seems like we're working fine here. Okay, so now we have all the bounds, 3 bounds, rectangles, top axis, and left numbers. What does this look like? This looks correct. Okay, and now we should have enough room here to put the numbers. Okay, so int current row 1. Well, I mean row count. I mean, there's at least 1, and every time we go in here, row count increments. Okay, 4. Int row equals 0, row is less than row count, row. So row string builder scratch format row and string row str is that mu rect left number rect is mu rect. So this is going to be left numbers bounds x, left numbers bounds y, left numbers bounds width, and well, I mean it's font height. And every time through here, left numbers rect y plus equals left numbers rect height. so it's mu, what is it, draw text or something, mu draw text. Mu draw text, context, font, roster, butter, so it's just roster position. Well, position is left numbers rect. Actually, it's just position, right? So we just need mu vec2 here. Row number pos is mu vec2 top axis bounds left x top axis bounds y row number pos. So like that. Mu row number pos y plus equals font height. Mu color and just some kind of gray. Yeah, something like that. Of course, we need to start at 1. It's one thing, right? We need to start at 1 and then go until we are equal to row count. So there are 12 full ones. It's misaligned, but there are 12 full ones, and 13th one is not complete. It's not quite complete. It also doesn't seem right because this is 12,600, so presumably the 13th one should be like up here. But it's not. That's weird. Yeah, assuming that all of these are actually 1,000, which they should be. If anything, they're even less than 1,000. So, because this doesn't quite fit, right? So that's interesting. Why is this not going all the way over there? And why are they misaligned? Yeah, because it's top axis bounds. No, it's left numbers bounds. So we can solve that problem. And we did. Okay, so the first problem solved. The numbers are aligned. Kind of. This. At least nothing's weirdly moving around here. And the second time you go in here, it's fine. Okay, well. Okay, so while we fixed the alignment issue, the only other issue is that why are they not quite adding up to 12,645? I mean, one thing we can make sure of is that they actually add up to 12,645. Int temp score 0, temp score plus equals round score. Assert temp score equals 12,645. It is 12,645. Well, if it's 12,645, then why are we not And why is this here? Well, actually, let's put the score back, and I'm like, if temp score is greater than 1000, break. Well, now it's not going to be 12.645, obviously. So that's greater than 1000? Oh, it's the first time it becomes greater than 1000? Well, I am using a different metric here for... So I break when I'm out of bounds. But oh, rounding, right? Yeah. So we need to be using the same metric here. If... yeah, we need to... this isn't the temp score anymore. Score sum. If score sum... Yeah, well, I mean, it's like here. So round rect width is that, score sum is that. And then we have to say, well, if score sum is greater than 1000, then break. And score sum, and it just reset it. Well, actually, don't reset it to 0, set it to round score. Okay, well now it looks about right, actually. Although, well, I mean, yeah, I mean, this works. I mean, there's a bit of a gap here, but I think we can live with that. At least you can count them, right? So like 12,000 and then something like 700, so yeah. Because it's greater than halfway. Alright. Yeah, there is this work out the height. Well, work out the height, and there is also visualize part 2. Alright. Oh my god. I wonder, right? So, about this one. If I kind of force it to loop, then which I can do, I guess, here. Well, let's pull a message, right? Oh god, there's a peak message. Filter min, filter max. pick message, message, hwind 00 and PM remove. Yeah, let's just, for now I think that's enough to make it like loop every time, and now that it's looping every time, you don't see that first frame where the layout's wrong. And we're still running apparently, okay, well, because we didn't get -1. Yeah. I mean, if at any point there is any reason to transition to peeking messages rather than getting them, then this one extra frame of desync is going to be a lot less of a problem. But as it stands, yeah, it's a problem. I mean, I guess I mean, there are some hacks you can do, like, well, if we get the message, except we peek the message first and see if there is anything, and if there is something, then we loop over twice. Like, we always keep, whenever we hit a frame where there is no messages for us to process, we just loop over once again, and then we hang and get message after that, which is just annoying. But I mean, that will hide that. I mean, ideally, you just wouldn't have that problem. Like, why is it not synchronized right away? But only the first time you draw it, it's not. The second time you draw it, what was that black rectangle flash? What was that black rectangle flash? What was it? So annoying. So annoying. Alright, anyway, let's see, what do we got? Part 2. Visualize part 1 of day 2. Alright, that's it for today. See you later.